Now, in this last part of chapter 14, we're going to look at the nomenclature of benzene derivatives. We're going to start with the nomenclature of monosubstituted benzene derivatives. Monosubstituted means that we have one substitution coming off of our benzene ring. Now, the nomenclature of a monosubstituted benzene derivative is really straightforward. You're going to name the substituent and follow it with benzene. So this would be fluorobenzene. And be careful about your spelling. Fluoro is F-L-U-O-R-O. If we have a chlorine substituent, it is chlorobenzene. If it's a bromine substituent, it is bromobenzene. And if it is a nitro substituent, it is called nitrobenzene. So I think this also introduces a new substitution to us. The NO2 group is called nitro. Also, I apologize if the sound quality has gone down in this video. It is now pouring outside, but I really need to get this video to you guys, so I'm really sorry if you can't hear it very well. So our monosubstituted benzene derivatives also has one small complication. There are some commonly accepted parent names, meaning these are common names that are now serving as parent names, just as like hexane is the parent name to any 6-membered substituted alkane. So this first compound, we could call it methylbenzene. That would be the IUPAC name, but the commonly accepted name is toluene. And so this is the name that I actually want you to use. Making flashcards for these would be really great. This next compound is phenol. When we have an amine substitution, the NH2 substitution, the compound is called aniline. The next one is a carboxylic acid made from benzene. This is called benzoic acid. Our next one is benzene sulfonic acid. The next one, this ketone, is acetophenone. And then when you have a methoxy substituent, it's called anisole. There's also another one that you already know. Which is benzaldehyde. So again, flashcard these, you do need to know them and you will use them in your other aromatic names. When you have two substituents, the process is not much more complicated. You just have to double check something first. So the first question is there a parent compound present? If not, you don't have to worry about it, but if there is, you're going to have to indicate that. And then you need to indicate the relative positions of your substituents using numbers, or we have a new method of naming called ortho, meta, and para. So ortho, meta, and para correspond to positions on a benzene ring between two substituents. So when the substituents are on neighboring carbons, this is called ortho. When there is a carbon in between them, it is called meta. When they are across from each other, they are called para. So that's part of our nomenclature here. Now in this first compound, we don't have a parent compound present. We just have two bromine substituents. So when you have two of the same substituent, remember you have to use a prefix to indicate that. So we're going to call this dibromobenzene. However, we also have to indicate their relative position to each other, because two bromines could be ortho, meta, or para to each other. So we can call this O dibromobenzene, or you can spell out ortho, or you can call it 1,2 dibromobenzene. Either way would be correct. In our next compound, we actually do have a parent compound present. We have phenol, and the phenol has been substituted by a bromine substituent. So that makes this compound bromophenol. And now we have to indicate also our positions. So we're going to call this M bromophenol, or you can call it 3 bromophenol. When you have a parent compound, the carbon that the parent is on is automatically carbon number 1. So we do not have to say 1,3 bromophenol, because the use of the parent name already suggests that that is carbon number 1. So 1, 2, 3 bromophenol. In our next compound, we have two parent compounds present actually. We have phenol and we have benzoic acid. Benzoic acid is going to have the priority over phenol. And they're in the para position. The substituent name for an alcohol is hydroxy. So this could be called P or para hydroxy benzoic acid. Or you can call it 4 hydroxy benzoic acid. Now, students always end up asking me, how do I know which one is the highest priority? The way that you know is that I'm just going to kind of tell you as we go. So benzoic acid is the highest priority of all of these substituents. So in the next one along the bottom, we have nitrobenzene and we have benzoic acid here. Benzoic acid is the higher priority. So this compound is called O nitrobenzoic acid. Or you could call it 2 nitrobenzoic acid. In our next compound, we have a chlorine and a methyl substituent. This one often trips students up because they assume a halogen must be more important than a methyl group. And in a lot of ways, yes, it is. But in this compound, toluene is a parent compound and chlorobenzene is not. So this becomes a substituted toluene. So this is M-chlorotoluene, or you could call it 3-chlorotoluene. Now in our last one, you're not going to call this methyl toluene. That's kind of weird. When the substituents are the same, even if it would create a parent compound to have just one of them, you end up indicating both of the substituents the same way that we did up here with 2 bromines. So the correct way to name this would be 1,4-dimethylbenzene, or you could call it P-dimethylbenzene. But also a benzene ring that has 2 methyl substituents has another common name, and you can indicate it also with a letter. So this is P-xylene. If the 2 methyls were ortho to each other, it would be orthoxylene. If they were meta, they would be metaxylene. Now, when you have more than 2 substituents in your derivative, you still have to ask yourself first, is there a parent compound present? You're going to indicate positions by use of numbers. We do not use ortho, meta, and para for more than 2 substituents. The reason being, these 2 bromines are ortho to each other. These 2 are meta to each other. these two are paired to each other. How in the world do you go from that and come up with a name? You'd have to call it orthometapara, and that doesn't make any sense. So instead, you use numbers. You number the ring in the direction that gives you the lowest possible numbers overall, and you're going to list your substituents in alphabetical order. So this is all the same words, or all the same rules as when you're naming cyclohexanes. The only exception here is that if you have a substituent that creates a parent compound, it is automatically number 1, even if that wouldn't be the best numbering scheme. You still have to make it number 1. So in our first example, we do not have any parent compounds. So we just want to number this in a way that's going to give us the lowest numbers. And our best bet is going to be 1, 2, 3, 4, 5, 6. So we would call this compound 1, 2, 4 tribromo benzene. In our next compound, we actually do have a parent compound, and so that simplifies it for us. This is automatically carbon number 1. Now, if we go clockwise or counterclockwise, it doesn't matter. We get to the nitros in the same amount of time. So we are going to call this 3,5 dinitro benzoic acid. So notice I'm not saying 1,3,5 because this is automatically carbon number 1. We don't need to say 1,3,5. Now in our last compound, we have toluene present as a parent, and we have 3 nitro substituents. So this is automatically carbon number 1, and then we have the same situation of it doesn't matter which direction we number in. So the name for this compound is going to be 2,4,6 trinitro toluene. And again, we don't use the number 1 for toluene because we don't need to. It's automatically number 1. Now, normally I would ask if anybody knew the name of this compound, but since this is a video and you can't respond to me, this compound is trinitrotoluene, also known as TNT. The last thing that I want to talk about before we do a couple practice problems is that you need to remember that benzene can also be a substituent. And the situations where benzene is a substituent are when it's attached to a larger chain, so a chain with more carbons, or when it's attached to a chain or cycloalkane that's containing a functional group or multiple bond. That's going to make that piece of the molecule a higher priority, and the benzene will be a substituent. There are 2 benzene substituents. We have phenyl and benzyl. Remember that phenyl means that the benzene ring is directly attached to the rest of the molecule. Benzyl means that we have benzene, we have a CH2 group, and then the rest of the molecule. An easy way to remember this is that phenol has the alcohol directly attached to it. So this is phenol. Whereas if you have an alcohol that's one removed, it's called benzyl alcohol. So maybe you might not recall benzyl alcohol immediately, but you should know the structure of phenol, and phenyl is going to have the same connectivity as phenol. So we're going to look at these examples. In all of these examples, the benzene ring is the substituent. So go ahead and push pause and see if you can name these on your own. Okay, so hopefully you pushed pause and you took some time and came up with a name on your own. In the first molecule, we have an alkene present, so that's what makes the benzene a substituent. The alkene is going to be numbered from the bottom here because that brings us to the benzene more quickly. So this is 1, 2, 3, 4. So we know that our parent chain is butene. Our substituent is directly attached to the butene chain. So our substituent is phenyl. So that gives us 2-phenyl, 2-butene. Now the other thing that we have to do, and it's really, really easy to forget, is to indicate whether this alkene is E or Z. Remember that you cannot use cis and trans here because the two methyl groups are cis to each other, but the methyl and the phenyl are trans to each other, so that's not going to apply. So we look at this carbon, and we have to choose between phenyl and methyl, which one is the higher priority. We're going to end up picking phenyl. And then on this carbon, we have a methyl versus a hydrogen. The methyl is the higher priority. Since our two substituents are across the double bond from each other, that makes this an E alkene. So E, 2-phenyl, 2-butene. In our next example, this one is much simpler. We have a long carbon chain. It has more carbons than the benzene ring does, so that makes it the priority. So this molecule has a phenyl substituent. This is going to be 2-phenyl heptane. Okay, in our last example, this part of the molecule is more important because it has an alcohol. So the benzene and the CH2 that separates it from the rest of the molecule are going to be the substituent. So this is the benzyl substituent. The rest of the molecule is cyclopentanol. This would be carbon number 1. This is carbon number 2. That makes this molecule 2-benzyl cyclopentanol. Now, if you don't remember the naming of cyclic compounds, that is something that you definitely need to go back over on your own. And if you have questions, make sure that you come to office hours. So we're going to do a couple practice problems in naming aromatic compounds. Go ahead and push pause so that you can work through this on your own. Okay, welcome back. Hopefully at this point you've already worked through this and you have your answers written out. Now this first compound is kind of a tricky one. So you can see the chlorine here, and that probably gives you a hint that the benzene is going to have to be a substituent because you have a functional group on the alkane. Now the tricky part is, how am I going to number this? I could number that way, 1, 2, 3, 4, 5, or this could be carbon number 1. Now you may remember from chapter 4, I think, when you first learned about naming compounds, you learned that one of the rules is you want to have the largest number of substituents. If you have 2 different numbering routes to choose from, you want to give yourself the most substituents. So if we go with the red one as number 1, we're going to have a phenyl substituent, we're going to have a methyl, we're going to have a chloro. If we go with the other route, we're going to have a benzyl and a chloro. So it's going to be the red route that actually wins. Now, one of the things that I see a lot is students struggling to put all their pieces together. So what I would do if I were you is just go ahead and list out my substituents before I bother alphabetizing anything. I have 1 phenyl, I have 2 chloro, and 2 methyl. So 2 chloro is going to be my first thing. And then we're going to follow it with 2 methyl because M comes before P. And then follow it by 1 phenyl. And then our longest chain is pentane. Now, the next one is kind of a head scratcher. Definitely the easiest name and the one that I'd be happy to accept would be to use the common naming for ethers. So you have a benzyl group, you have an ethyl group. We could call this benzyl ethyl ether. And in fact, that is the name most frequently used for this compound. This compound is kind of interesting because it kind of has like a fruity smell, but it's found in cocoa products. Now, in our last one, it looks a little tricky, but we have a cyclohexadiene as a base here, and then we have a substituent, which is the benzyl group. So all we have to do is figure out how we're going to number our cyclohexadiene. Our lowest numbering scheme is going to start down here. 1, 2, 3, 4, 5, 6. And we have the substituent 2-benzyl. So 2-benzyl, and then 1, 3 cyclohexadiene. Whoops. Cyclo. So the most common mistakes that I see in this type of naming is students forgetting cyclo or forgetting the di. That's definitely the most common mistake, is you get one but not the other. So make sure that you get them both. Make sure that you fully describe the molecule.